As the architecture profession hurdles into a period of green building, many architects, clients, and now the public at large are becoming aware that the green aesthetic that is marketed towards them is largely superficial. The realization of the superficiality of greenness has manifested itself in the term greenwashing, which broadly describes the marketing frenzy that has managed to label products as environmentally detrimental as bottled water and gasoline magically safe for consumption, without long-term consequences. Greenwashing in the architectural profession has often been used to describe elements such as double-skinned facades, louvers, green roofs, photovoltaic panels, and other superficial building elements that merely coat the surface of the building and communicate nothing about its deeper environmental impact. This current practice of greenwashing by means of slapping on additional elements of louvers and green roofs demonstrates that the profession's current approach to dealing with energy in architecture is always additive. One always starts with the same energy hog of a building and simply adds things to it in order to make it greener. Accordingly, in this additive practice, we complicate the issues of energy and climate far beyond the level that they need be considered. Our buildings become convoluted and complex contraptions, which occupants cannot understand or interact with, leading to a hopelessness about climate change as an issue far beyond their control. Looking at these cases that complicate the issue, one feels compelled to ask, how in the world do these situations happen? The answer lies in the current design paradigm, which we can imagine as a system of feedback loops, in which each turn of the loop represents an iteration of the design. Typically, an architect will start with some type of external inspiration, whether this is a response to the work of their contemporaries, a notion in philosophy that is of particular interest, or a vision shared by their architectural firm. When this inspiration results in the realization of a design opportunity, a building partie is born. Alternatively referred to as the big idea, the partie is the chief organizing thought or decision behind an architect's design and is frequently presented in the form of a basic diagram or simple statement. Forming the core of the design process, the architect will frequently come back to the partie throughout the process to re-evaluate it. Once a partie is established, the designer will bring in aspects that are specific to a client's project, such as the site of the project, the function that the building needs to house, and the aesthetics of the client's taste. The architect will present a design to a client numerous times throughout the design process, and with each design iteration, decisions are made and the number of possible future designs becomes narrowed down. On the other hand, this decision-making process has an increasing effect on the level of detail in the project, which rises exponentially in a positive feedback loop as more and more decisions are made. In the current design paradigm, it is only after a certain number of iterations of this cycle that engineers and energy consultants are brought into the feedback process to address technical concerns. These consultants help in the final iterations of design, giving a small amount of feedback before signing off on a project for code approval and submitting construction documents. Instantly, if one looks at this process, the reason for the current additive, complicating greenwashing paradigm becomes apparent. If consultants are only brought in at the end of the process, in the last few iterations when very few future design possibilities exist, all that they can do is add in shading and HVAC gadgets to a situation that is already doomed to be wasteful. Thus, in order to ameliorate this situation and make smarter decisions earlier in the design process, the initial inspiration of the architect should come not from an egocentric vision or response to their competitors, but should relate to something found or discovered in the climate, materials, and culture of the location in which the project is to be built. Moreover, the technical consultants and the considerations of the site will have to be brought on earlier in a manner in which they can help legitimize some of the design opportunities seen in the inspiration and help shape the initial partie. Accordingly, instead of the layered approach of bringing in different concerns at different times, this new design process would involve a simultaneous engagement with the client engineers, and energy consultants throughout the iterations until the final construction documents are produced. There have been many attempts to follow this new paradigm in recent years, under the banner of what the profession has termed integrated design. However, in the attempt to follow this paradigm, one instantly finds oneself in a predicament. This is that almost all of the tools and technologies that have been developed to date are meant for this older paradigm. The architect's tools are meant predominantly for the development of wasteful designs, while the technical consultant's tools are meant predominantly for the analysis of wasteful designs. Furthermore, even when one tries to edit or adapt these old tools in order to be more creative with them and answer new questions, one often runs up against the issue of proprietary software, being unable to change or edit the code of these tools. For this reason, a community of students, designers, and technical consultants have started an open source project to develop these badly needed tools using a radically different software development paradigm. Instead of the top-down development of the current proprietary tools meant for narrow applications to just a few situations, the current set of tools is being developed alongside their application, allowing for a diverse range of questions to be asked and experimented with creatively. This simultaneous design and tool development is accomplished through an online community forum that includes coders, professors, and building scientists, as well as users who apply the tools towards creative projects, either in the real world as professional architects or as students in the context of architecture school. There are also many individuals who straddle the line between these two as designers who, in the process of using the tools on a project, will simply open and edit the code of the tools or even make new tools off of the existing kit to use them towards their own unique creative ends. True to the nature of this distributed development process, the tools are organized as a set of individual components that can be linked together and recombined to answer new and interesting questions. For example, two components linked together will import weather data into the interface, such as hourly temperature and location. Taking the location data from this import and connecting it to another component will draw a sun path diagram right within the 3D environment in which the designer works. Linking up another set of tools will show the areas of the sky dome where the most radiation is coming from and reveal design opportunities, like a band of bright sunlight occurring in winter, right at the time when heating load is most at its peak. Connecting another set of tools will show how this wintertime radiation falls over the existing site, and yet another set of tools will create the volume of a solar fan for this band of winter sun, showing the volume that must be clear of obstructions in order for the sun to reach the site of the proposed building. As one can see from these examples so far, these tools are built with a plugin called Grasshopper off of the architect's primary 3D design software, Rhinoceros, and this allows for both an easy access in the design process, as well as the ability for energy consultants to run mathematical calculations and advanced simulations from the Grasshopper window. As one can also see from these examples, the tools can help designers explore the climate and find sources of inspiration, like the band of wintertime sun that can be used for heating. This can then lead to design parties, such as a party that captures and focuses this band of sunlight using reflective parabolic forms tuned to capture the sun at different hours of this band and reflect it onto a thermal mass that will store the solar heat for use throughout the cold winter night and day. The kit of energy tools also includes a means of quickly testing such parabolas for their focusing ability, such as a sun ray tracing tool, which will show how the sun rays are reflected and how well they can be focused. At the same time that the designer experiments with these fast analysis tools during design development, the energy consultants and engineers can run full energy simulations using another set of tools included in the kit. It should be noted that these advanced energy modeling tools are built to run almost any geometry that the architect can dream up, unlike most of the current proprietary tools that favor simple forms such as boxes and gabled roofs. As the engineer ensures that the performative aspects of the partie are working correctly, the architect simultaneously can use the simpler ray tracing tool to ensure that the path of the sun remains clear as structural elements are brought in, along with the rest of the building's functions. Ultimately, this helps ensure a design that can technically make significant progress towards the elimination of a heating system in winter, while also allowing for the evocative aspects of a building that the designer and occupants cherish. This example is just one of many possible buildings that lay hidden in the inspiration of the local climate, and there are countless others just waiting to be discovered. With these tools and the impetus towards integrated design, there is hope that we can discover these new parties and move beyond the current greenwashing paradigm that merely adds things to wasteful buildings at the end of a design process. Go now to this webpage to download the tools and begin discovering your inspiration in climate.